The use of the scientific method unites these three fields of study, although it is more commonly used in the social sciences and natural sciences than in humanism. The scientific method is a systematic and logical approach in acquiring and explaining knowledge. It involves a step-by-step procedure of identifying the problem, formulating a hypothesis, and testing this hypothesis by gathering and analyzing relevant data. This method requires critical thinking skills in solving problems. The scientific method is very important in the field of social science since it is the instrument by which issues and problems are examined and recommendations for policy making are offered depending on the findings of the study conducted. The scientific method refers to a standardized set of techniques for building scientific knowledge, such as how to make valid observations, how to interpret results, and to generalize results. It allows researchers to independently and impartially test pre-existing theories and prior findings. It has the same objectives with research, which investigates and studies different materials and sources in the pursuit of advancing knowledge. A researcher tests his or her hypothesis by subjecting it to careful scrutiny and debate and finally comes up with a conclusion that either validates or disapproves the hypothesis. In the field of social science, research is an indispensable tool in addressing social issues and problems. Through research, a social scientist can try to find answers to questions like, what is poverty? Who are the poor? Why does poverty exist in society? How can society best address or solve the problem of poverty? In pursuing research, the use of scientific method is required. According to Rajasekharan in 2013, the steps in the scientific method are as follows. 1. Defining the problem. 2. Reviewing the literature. 3. Forming hypothesis. 4. Collecting and analyzing data. And 5. Drawing conclusions. The application of the scientific method to social science research simply involves the use of its steps or procedures to specific research interests. According to Garge in 2012, the stages of the research process below can serve as a guide in pursuing research. As you can see, in the different stages of the research process, there are key questions to answer. Take for instance, on the first stage, define the research problem. Key questions include, what are the variables or the units of analysis being studied? What is the time frame or period of the study? For stage 2, review the related literature. Key questions, what has already been written about the topic? What are the research gaps? For stage 3, formulate hypothesis. Key questions, what are the specific parameters of the research problem? What are the means of manipulating the variable and or measuring the result of the study? For the next stage, prepare the research design. Key questions. Is the research going to be descriptive, exploratory, or experimental? How should the sample be selected from the population? Next stage, collect data. Key questions. Will the interviews be done personally or over the phone? Who are the target participants of the survey? For the next stage, analyze data. What do the data reveal about the relationships of the variables being studied? How do the data answer the research problem? And for the last stage, interpret the results and write the report. Key questions. What are the social implications and significance of the findings? Are the sources, both primary and secondary, properly cited in the study? Before I discuss the different types of research designs, let me first give you a very brief definition of what research is all about. Watch the next video.
What is research? Research is a planned investigation carried out in an organised and systematic way. It produces information called data which, when analysed, tells us things we did not know or were unsure about before. When applied to practice, this new understanding may influence what we do. We need to ask questions at the start of the investigation, collect data, then use it to answer the questions, connect the investigation to what is already known, look carefully and critically at our data to see if it is trustworthy, and present what we find in clear, precise and persuasive ways. Research is also part of educators' reflective practice, thinking hard about what you do, assessing its value, and working out how things might be done better. Researchers work with different sets of beliefs called paradigms. Paradigms are the conscious and subconscious beliefs which lie beneath the questions we ask and ways we carry out research, and which shape the kind of conclusions which emerge from our investigations. Positivist researchers prefer hard data like numbers and facts. Interpretivists prefer people's experiences, beliefs and perceptions. So, different researchers working in different paradigms might approach the same research question in very different ways. To answer the question, why is the sky blue, a positivist physicist might collect data about how our atmosphere interacts with light from the sun, whereas an interpretivist anthropologist might collect data about different cultures' creation myths. The different approaches would produce very different answers, but both would be true in their own way. Positivist approaches are associated with research which involves evaluating the effectiveness of particular practices, determining cause and effect, or comparing one situation with another. Interpretivist approaches are associated with research which involves investigating everyday actions in classrooms, in-depth investigation of particular cases, or exploring issues from varied perspectives. In the end, you may draw from both paradigms, combining firm data with interpretation of experiences. Whatever standpoint you use, you need to be able to explain and justify it. So keep paradigms in mind when choosing your methodology.
Design. The research design sets the direction of the whole study. According to Salyus et al., as cited in Mukul Gupta's book in 2011, Research Methodology, research design is the arrangement of conditions for the collection and analysis of data in a manner that aims to combine relevance to the research purpose with the economy procedure. The research design determines the type of data that will be used in the study, the methodology that will be used in gathering and analyzing data, and the direction of the narrative, which ultimately addresses the research problem. The different research designs are descriptive research, historical research, experimental research, exploratory research, cross-sectional research, longitudinal research, sequential research, case study, and meta-analysis. Descriptive research. It provides answers to basic questions associated with the research problem. It may not be able to conclusively provide the answer to the question why, but it is able to describe what exists with respect to the variables of a given situation. For example, a descriptive study of the factors that lead to domestic violence. Historical research. This design collects, verifies, and synthesizes evidence from the past in order to validate or reject a hypothesis. It uses secondary sources and a variety of primary sources like newspaper clippings, diaries, government records, and archival materials. Example: martial law in the Philippines, the golden or the cursed years in the country's history. Experimental research. This type of research answers the question, what causes something to occur? This design uses both an experimental group and a control group, which allows a measurement of the dependent variable when the independent variable is administered to the experimental group and not to the control group. Example: a study on the effect of sleep deprivation on health and productivity.
Psychology in the Fast Lane. Difficult topics explained. Experimental design. Think of the experimental method as a way of isolating what is causing something to happen. Here's a simple example of isolating a cause. You notice that your car is making a squeaking noise when it's running. You walk around the car and listen for where your sound is coming from. You notice that one of the parts is wiggling around. By listening to locate the source of the sound, you used your auditory perception, and you've confirmed it with visual perception. So you hold it in place and the squeaking stops. You let it go and the squeaking continues. After repeating this action, you can conclude that the wiggling part is the cause of the sound. Tighten up that part and you now have a quiet car. First you observed the squeaking sound, then you described it by pinpointing its location. Then you made a prediction, or you hypothesized, that the wiggling part may be related to the squeaking sound. Then you tested your hypothesis by stopping the wiggling part and observing the sound stop. You repeated the test and compared the non-wiggling and wiggling conditions, or the control and experimental conditions. Then you came to a conclusion. The wiggling of the part is causing the squeaking noise, and you acted, tightening the mechanism to keep it from wiggling, and you fixed the problem. Science at its most basic. Now, let's look at an example from the psychology field. A group of neuroscientists observed that people with traumatic brain injury, which is severe brain damage caused by physical accidents, have difficulty recognizing facial emotions very well. They formed a hypothesis that TBI leads to impaired recognition of emotion in faces. Their solution was to create a group exactly equal to the TBI group in every way except having TBI. Same gender, sociocultural, and age characteristics, just not brain damaged. Then they tested each group by showing them pictures of faces and asked them to identify the emotions in the pictures. They found that the TBI group did in fact recognize fewer emotions accurately, an average of 15 out of 20, compared with the control group's 18. They concluded that TBI does cause impairments in recognizing facial emotion. Just remember, the experimental method is designed to determine the cause of something by isolating
This
the
design tackles
hypothesized
research
causes
problems
and
that have
comparing their
little
control
or no
results.
previous studies done on it. It aims to develop tentative theories or hypotheses on research problems that are still in the preliminary stages of investigation. For example, a comparative study on the effectiveness of same-sex parenting via conventional parenting.
Hello class, can I explain any marketing concepts?
Professor Siegfried, can you explain what is exploratory research?
Well Suresh, exploratory research is research that gathers preliminary information that will help to define the problem and then suggest a hypothesis. For example, Unilever, which makes Streets ice cream, might want to find out if a new adult flavor will add to its Magnum brand ice cream sales and profits, or cannibalize existing sales. Exploratory research often relies on secondary research such as reviewing available literature and/or data, or qualitative approaches such as informal discussions with consumers, employees, management or competitors, and more formal approaches through in-depth interviews, focus groups, projective methods, case studies or pilot studies.
Cross-sectional research.
Thanks, Professor, for this
This
explanation.
design measures similarities or differences across groups and subjects. A specific variable is examined across different groups or subjects. It is rather limited because it does not capture the process of change following intervention. Example: a study on the incidence of breast cancer across different age groups of women. Longitudinal research. It studies the same sample across time or across regular time intervals. This type of study allows researchers to track changes that occur over a period of and identify the variable or variables that might be causing the changes. For example, a study on the effect of TV programming to violent behavior among children.
Longitudinal studies help to paint a clearer picture of society by helping us understand how life is changing. They observe the same groups of people repeatedly over a period of time. Birth cohort studies follow groups of people born at a particular time. Every few years, researchers contact these people to ask them questions about their lives. In household panel studies, whole households are surveyed, including parents and their children. Study members are interviewed every few years to show how life is changing in homes across Britain. When designing a study, researchers might be interested in the population as a whole, or they might select a group of people based on factors such as their age or health. Data can be collected from study members face-to-face, on the phone, by post, or online. Many also take part in health and cognitive assessments. Information from the studies helps to improve people's lives by informing government policy in areas such as health, education, and employment.
Sequential research. This is a type of research design carried out in a series over a time interval. It has no predetermined sample size, as the researcher can accept the null hypothesis, accept an alternative hypothesis, or choose a new set of samples and repeat the study once again. Example: a study on the effects of diet, exercise, and common medication on heart disease conducted across different age groups.
created using Powtoon.